Welcome to the AI Coach by Anil Nathu. You know that feeling when you're trying to gather information across your team, and it just feels like you're playing some complex, frustrating game of telephone, or maybe you're trying to synthesize like a mountain of articles for a crucial report, maybe for a client or a big strategic board meeting. And it feels like you're just chasing ghosts across different systems, different people. It's not just inefficient, it's frankly a massive drain on time energy. And it can lead to missed deadlines or, worse, incomplete insights that really impact key decisions.
Oh, absolutely. It's such a universal pain point. I mean, in our deeply interconnected professional world today, effective collaboration isn't merely a nice to have, is it? It's absolutely non-negotiable for success. We're constantly, deluged with information, and the real challenge isn't just finding any information, it's figuring out who holds what precise piece of the puzzle. And this inherent fragmentation means information is often siloed. You don't always possess perfect knowledge of who holds specific expertise. And every single request, every ping, every email, it comes with that communication cost, that invaluable human effort required to process and provide a specific answer. This constant friction, it can dramatically slow down decision making, stifle innovation, and lead to pretty significant productivity losses within any organization.
And that's precisely why we're taking a deep dive into some truly fascinating new research today. It's a paper titled LM Agents for Coordinating Multi-User Information Gathering. This paper is penned by Harsh Shamtani, Jacob Andreas, and Benjamin Van Durham from Microsoft. And it introduces this really innovative benchmark they call PeopleJoin. This benchmark, it gives us a unique lens to sort of observe how large language model, or LLM, agents can step in as these automated assistants, helping us navigate these intricate collaborative challenges. Essentially, it's about transforming that complex, often frustrating game of telephone into something more like a streamlined automated flow of knowledge, making collaboration smarter and just, well, more efficient.
Exactly. So our mission for this deep dive is to thoroughly unpack the fundamental problem of information fragmentation that, let's face it, plagues organizations. We're going to meticulously explore how these sophisticated LLM agents are specifically designed to tackle it. We'll scrutinize their surprising performance results when they're put to the test, and then we'll really dig into the profound implications this research holds for the very future of AI-driven collaboration. We'll journey through some real-world scenarios, draw on specific examples directly from the research paper, and help you grasp what all of this means for you personally, including, practical ways you might apply these cutting-edge insights to make your own collaborative work more productive. Think of it as a deep dive into how to build a smarter team, whether human or AI-powered, with the kind of strategic thinking you'd get from, say, an AI coach by Anil Nathu.
Okay, let's really unpack this core challenge, though.
Yeah.
The paper opens by powerfully highlighting the sheer necessity of effective collaboration in our modern work environments. And it's, like you said, far more than just sharing documents in a shared drive or, a cloud folder. It's about actively collecting specific, often elusive pieces of information from multiple people to accomplish complex, frequently time-sensitive tasks. Just pause for a moment and consider your own daily workflow. How many times do you find yourself needing to reach out to different colleagues, sending emails, making calls, maybe popping into IM chats, just to piece together a full, accurate picture of something?
It really is a constant, almost invisible part of our professional lives, isn't it? The authors, Jamtani, Andreas, and Van Derme, they provide some incredibly relatable real-world examples that, hit close to home for anyone who's worked in an organization. Imagine, for instance, you're tasked with preparing a comprehensive list of all interns currently working across various teams in a large organization. Now, this isn't usually a simple matter of pulling a neat report from some HR system. It invariably requires direct outreach to each team leader, maybe in engineering, marketing, sales, product development. And each of them might maintain their own unique, maybe informal records or have specific nuanced details about their interns. You're trying to aggregate specific data points like individual start dates, assigned projects, or even just updated contact info. And that absolutely necessitates a series of individualized communications and likely follow-ups.
Right. Or let's consider another really common scenario. Drafting a company newsletter. This is definitely not a solo endeavor, is it? It requires meticulous coordination with multiple contributors from different departments for their specific updates. You need engaging articles from marketing about recent campaigns, maybe crucial input from HR on new hires or policy changes, updates from product development on upcoming features or releases, and perhaps even, a personal message from the CEO. Each distinct piece of information originates from a different person, often with varying timelines, different levels of detail, all needing to be meticulously compiled into one coherent, engaging narrative. It's a real masterclass in distributed information gathering.
And perhaps the most common yet surprisingly intricate example the authors cite is simply scheduling a meeting. I mean, this seemingly straightforward task often just explodes into several rounds of negotiation, back and forth emails, calendar juggling, just to find a suitable time slot for everyone involved, especially when you're dealing with multiple time zones or the packed, often unpredictable calendars of senior execs. You're not merely looking for basic availability, you're frequently managing preferences, maybe prioritizing attendees based on how critical they are, and dealing with those inevitable last-minute changes. Each of these scenarios, as the Microsoft researchers astutely identified, is just ripe with inherent challenges when handled through traditional human-driven processes.
And these challenges, as the paper meticulously details, are quite significant, aren't they? First, there's the sheer difficulty of just identifying what information is even available, and more important, where it precisely resides, like who actually possesses the data I desperately need right now. Second, once you have a vague idea, it's about judiciously determining who to contact. You certainly don't want to needlessly bother everyone in a department, right? But you absolutely cannot afford to miss the one or two key people who hold that critical information. Third, asking precise questions is just paramount. A vague or poorly framed query invariably leads to equally vague, unhelpful answers, demanding more exhausting back and forth. And finally, there's the formidable complexity of compiling research results from disparate, often unstructured sources into a cohesive, truly useful answer, coupled with the inherent difficulty of real-time interaction coordination across multiple human team members. It's a staggering amount of manual overhead, and frankly, it sounds like a recipe for burnout.
Yeah, it does. And this naturally raises a fundamental question, one that's really at the heart of this research. Can large language models, these incredibly powerful AI models like OpenAI's GPT-4 or, Microsoft's Phi 3, truly step in as sophisticated automated agents? Can they effectively assist humans with these complex multi-user tasks? The authors reference the rapidly growing role of LLMs in existing successful applications, citing examples like Microsoft Copilot Chat for searching and summarizing internal info, and even supporting workplace decision-making by pulling disparate data together. The core innovative idea behind PeopleJoin, therefore, is to generalize existing, well-established approaches for querying structured databases. Think of traditional SQL queries over tidy tables, to a far more dynamic, human-centric environment where the knowledge base isn't some neatly organized digital repository, but rather information inherently distributed and held among real people.
So what's truly fascinating here is how the underlying concept directly connects to problems that have been rigorously studied for decades in traditional database systems. Things like query optimization and federated databases. Like, imagine a sophisticated database system trying to efficiently pull information from multiple linked tables spread across different servers. Now, instead of querying a centralized, perfectly structured knowledge store, these AI agents have to obtain that crucial information via natural conversation, meticulously reflecting the often messy, real-world organizational dynamics, where information is frequently siloed, sometimes imprecise, and primarily held by individuals rather than easily accessible digital repositories. It's a profound shift in how we even think about data, isn't it?
That's a very perceptive way to put it. This fundamental shift from querying pristine, structured data to interacting with human-held, conversational data is the critical generalization this research explores. It inherently implies a much higher level of uncertainty, ambiguity, and the constant need for adaptive, nuanced interaction. The challenges for these AI agents are therefore multifaceted, mirroring precisely the complexities and frustrations humans face every single day in collaborative environments.
Okay, so given this backdrop, what does this all mean for the fundamental challenges AI agents themselves must grapple with when operating in this intricate, multi-user conversational environment? The paper clearly outlines 4 key hurdles that these nascent LLM agents have to overcome to be truly effective. First, there's the pervasive problem of information fragmentation. This, I'd argue, is at the very root of countless collaborative headaches in any organization. Information is almost always siloed across multiple users, right? It's a natural consequence of differing roles, departmental boundaries, specialized responsibilities. Imagine trying to stitch together a complete picture of a complex, cross-departmental project. The marketing team has their campaign metrics and creative assets. The engineering team holds the development timelines, technical specs, bug reports. And the legal team is managing compliance docs and contracts. Each distinct team possesses unique pieces of the puzzle, and critically, no single person or department holds the entirety of the necessary information. An intelligent agent needs to not only comprehend this inherent distribution, but also actively seek out and synthesize information from each relevant silo. It's not merely about what information exists, but precisely where it resides, and that where is often locked within the minds or personal files of specific individuals.
And that challenge, as you perfectly illustrate, flows directly into the second hurdle: partial observability. These AI agents, they don't possess perfect omniscient knowledge of who knows what. They have to continuously infer and deduce based on incomplete initial descriptions and the evolving context of previous interactions. This frequently necessitates multi-turn conversations to progressively refine requests and uncover deeper layers of information. It's strikingly similar to a human trying to identify the ideal expert within a sprawling organization when they only have, say, a vague job title to go on. Or perhaps just a rough, incomplete idea of what that person might know. You don't have a perfectly indexed directory. You have a collection of hints, clues, conversational breadcrumbs, basically. The agent needs to be astute enough to follow those leads, adapting its queries and its approach as it gleans more information from each interaction.
And this next point, to me, is absolutely critical for the practical real-world application and adoption of these agents. Communication costs. Every single message sent to a human collaborator requires their valuable effort to process, understand, and respond. If an AI agent just inundates people with redundant questions, or asks for information that's unanswerable, or simply broadcasts irrelevant queries to multiple individuals, it very rapidly transforms from a helpful assistant into an overwhelming burden, doesn't it? A truly effective agent must be rigorously efficient, meticulously avoiding unnecessary inquiries and minimizing this precious human overhead. It needs to be precise, targeted, and always respect the finite and valuable resource that is human time within any organization. This is where an AI agent provides immense value, not just in finding answers, but in optimizing the journey to that answer. Much like, a good AI coach by Anil Nithu would guide you to efficient workflows.
This is a subtle yet absolutely vital point, because the ultimate goal of AI in the workplace isn't just to do a task, it's to do it efficiently and respectfully from the human perspective. If the AI, despite its intelligence, inadvertently creates more work or friction through inefficient communication, it fundamentally defeats its purpose. It's about enhancing, not simply automating.
And here's where it gets truly fascinating. The fourth and perhaps most complex challenge: complex reasoning and planning. This is far beyond simple information retrieval. The agent needs to continuously, dynamically reason about multiple fluid factors like what information does it already possess from accessible documents or its prior conversational memory. This forms its evolving internal knowledge base. Then, crucially, it needs to dynamically predict which specific collaborators are most likely to hold the precise, relevant information it still requires. This demands a sophisticated understanding of roles, responsibilities, and even the nuances of past interactions. Furthermore, it has to identify the optimal order in which to ask questions like who should it engage with first to unlock the next critical piece of information, or maybe to be redirected efficiently. And, perhaps most critically, it must possess the ability to rapidly replan its entire strategy based on collaborators' responses. If a person responds saying they don't have the info but intelligently suggests someone else who might, the agent needs to pivot, adjust its plan, and pursue that new lead. It's a continuous, dynamic, and incredibly intricate problem-solving loop.
Exactly. These four challenges, information fragmentation, partial observability, communication costs, and complex reasoning and planning, they collectively underscore why simply deploying a powerful LLM isn't enough. It absolutely requires a sophisticated architectural framework to operate effectively and, frankly, considerately within a collaborative human environment. It's fundamentally about orchestration, not just raw generation of text. And that's precisely what this groundbreaking research aims to address. How do we build agents that are not just intelligent in a vacuum, but also strategic, adaptive, and genuinely considerate in their complex interactions with people?
Okay, so to rigorously evaluate these complex capabilities, the researchers meticulously developed PeopleJoin, which, as you said, stands as a novel benchmark for this kind of multi-user information gathering. It's an evaluation framework where each task unfolds within the context of a fictitious organization. Cleverly designed to range in size from like a tiny startup of 2 employees all the way up to a medium-sized company with maybe 20 employees. And crucially, within these simulated organizations, some of these employees possess specific documents or unique knowledge that are absolutely essential for solving a given task. This ingenious setup creates a realistic, albeit simulated, environment for collaborative information gathering, allowing for really controlled experiments.
Yeah, and within this framework, the agent's role is quite specific and central. An initiating user, let's picture her as Alice, just to mirror one of the paper's illustrated examples, communicates a specific task or question to the AI agent. Now, this agent possesses direct, immediate access to Alice's own accessible documents, basically acting as an extension of her local files. But here's the crucial part. If Alice's documents alone aren't enough to answer the query, the agent then has the sophisticated ability to engage in dynamic conversations with other simulated users within the organization to gather the missing information. It has to cleverly utilize limited initial descriptions of these other users and potentially insights gleaned from past interactions to intelligently determine who is the most relevant person to contact. It's an active, conversational, and iteratively refined information-seeking process.
And what's particularly clever is how this benchmark is designed, right? The researchers ingeniously repurposed existing high-quality natural language processing, or NLP, datasets. This ensures that the tasks are genuinely complex and realistic, moving far beyond just, like, simple toy problems. They essentially took two well-established datasets and masterfully transformed them into these dynamic, multi-user collaborative scenarios. First up, they created PEOPLEJOIN-QA, question answering over tabular data. This domain was adapted from Spider, which is a pretty renowned text-to-SQL benchmark. Spider originally contained over 200 distinct databases and more than 10,000 diverse questions, all designed to test an AI's ability to translate plain English questions into precise database queries. The researchers basically took Spider and brilliantly turned it on its head for this project.
Yes, their transformation process was quite inventive. They took each original Spider database table and converted it into one or more documents, which were then strategically distributed among the various users in the fictitious organization. The original Spider questions then became the complex queries from an initiating user like Alice to the AI agent. So think of it like this. Alice asks a question that, in a traditional database, would require performing a join operation to combine data from multiple tables. Here in PeopleJoin, those tables are no longer abstract data structures. They are now specific pieces of information held by different individuals across the simulated organization.
That analogy is incredibly strong and insightful. It really helps bridge the gap. Answering these questions now requires the agent to first identify which specific users possess the relevant pieces of information, much like selecting which tables to query in a relational database. But instead of writing a precise SQL query to join those tables, the agent has to engage in fluid, multi-turn conversations with these different individuals, which is kind of like dynamically constructing complex joins between tables through an evolving dialogue. It's a brilliant conceptual leap to simulate real-world information retrieval in a very human-centric way.
And this is precisely where the paper truly excels in creating truly realistic simulated organizational challenges, which they achieve through what they call document transformations. This isn't just about simply splitting up a spreadsheet, it's about artfully modeling the inherent messiness and complexity of real organizational knowledge and information flow. First, they implemented split documents. A randomly selected table from the original Spider dataset is meticulously split into two distinct parts, with each half then assigned to a different user. This directly simulates pervasive real-world scenarios where information about a single cohesive topic is, by its very nature, fragmented or distributed across multiple individuals. The paper provides a fantastic illustration in Figure 2, where crucial department information like department ID, name, budget details is intentionally split between Alice and Dante. So if you as the agent needed a complete, holistic picture of a particular department, you would logically have to engage in conversation with both individuals to piece it together. This type of fragmentation occurs in about 25% of the benchmark's test instances.
That really resonates. It's such a common scenario, isn't it? You might get half a report from one team lead and the crucial other half from someone completely different. The agent needs to not only recognize that fragmentation exists, but then intelligently piece those separate parts together to form a complete answer.
Absolutely. Next, they introduced redirection. In this scenario, some users, like Chen in Figure 2, don't possess direct access to certain specific information themselves, but they do know precisely which other user, in this case Dante, actually holds that information. This means that agents cannot always directly contact the most knowledgeable users. They have to skillfully navigate this organizational knowledge hierarchy, often relying on internal referrals. It's like when you ask a colleague, hey, do you know about X? And they thoughtfully reply, no, but I think Y might be the person you're looking for. The agent must be intelligent enough to follow that lead, pivot its strategy, and pursue the referral. This critical dynamic is present in about 22% of the test instances.
That's a vital social dynamic to capture. It's not just about raw content.
It's about understanding and leveraging the intricate network of knowledge within an organization.
Precisely. And finally, they included missing information. In this scenario, a randomly selected table from the original dataset is entirely omitted from the simulated organization, rendering some queries inherently unanswerable. This directly simulates real-world situations where the required information simply isn't present within the organization's collective knowledge base, no matter how hard you look. The agent's sophisticated task here isn't just to find the answer if it exists, but to accurately and efficiently determine when no answer can be found, and then communicate that effectively back to the user. This makes up about 9% of the test instances, adding another layer of realism.
So the agent can't just keep asking indefinitely. It has to possess the smarts to know when to declare the task unanswerable, even if it feels incomplete. That's a truly sophisticated capability for an AI. And to simulate that crucial element of partial observability, they relied on user descriptions. Templated descriptions of each user's potential knowledge were first created and then intelligently converted by GPT-4 into simpler, but sometimes intentionally imprecise or incomplete English statements. For instance, a description like Chen might know about student demographics doesn't specify what exact demographic info Chen has or how it's linked. Is this by student ID, name, maybe just aggregate statistics? This adds a realistic layer of ambiguity, significantly increases the challenge of selecting the perfectly right person to contact with only limited upfront knowledge.
Absolutely. For the evaluation of PEOPLEJOIN-QA, they primarily use an answer match accuracy metric. This metric is scored on a simple 0, 50, or 100 scale by an LLM-based evaluator, specifically GPT-4 Turbo, which compares the agent's final response against a carefully curated gold standard answer. 100 is a perfect match, 50 is partial but useful, 0 is wrong or missed. Secondarily, and crucially for real-world application, they meticulously looked at efficiency metrics like the total number of messages sent and the number of unique people contacted, which is paramount for minimizing that human communication cost we discussed earlier.
And then there's the more open-ended creative task, PEOPLEJOIN-DOCCREATION, document
Okay,
creation tasks.
Right. This task, which was ingeniously derived from Multinews, a multi-document summarization dataset, it challenges agents to first gather source news articles or specific excerpts that are distributed across various users, and then meticulously combine them into a coherent target summary. It's a task that leans less on structured data and far more on synthesizing qualitative, often narrative-driven information.
So the organization structure for this task is also quite clever. Multiple problem instances are strategically combined into one overarching organization. Users might possess articles focused on a single subject, articles covering multiple diverse subjects, or even no articles at all, precisely mirroring how knowledge about broader topics might be widely spread or, conversely, highly concentrated within a real organization. For user descriptions in this domain, GPT-4 cleverly generates keywords directly from the user's documents, offering clues to the agent about a user's specific expertise without revealing all the details. Like keywords such as governor election, GOP, healthcare would suggest a user's focus area.
Exactly. And the evaluation for this document creation domain utilizes the ROGL score, which is a widely accepted metric commonly used for summarization tasks. It assesses the overlap of words and phrases between the generated and reference summaries. They also include G-eval scores, which is an LLM-based metric specifically designed to evaluate relevance, consistency, and coherence. And it's known to correlate well with human ratings for summary quality. This combination provides a robust and multifaceted assessment of the generated summary's quality, going beyond mere keyword overlap to evaluate the depth and sense of the content.
Okay, so we've meticulously set the stage. We understand the core problem, the innovative benchmark designed to test it. Now let's go under the hood, how the agents work. What exactly makes these sophisticated LLM agents tick? What's the underlying mechanism that enables them to navigate such complex collaborative environments?
Right. The research utilizes a reference LM-powered agent implementation that's precisely described as event-based reactive. This essentially means the agent isn't just some static knowledge base that passively waits for queries. It's an active, dynamic entity. It continuously responds to external inputs and observations in a feedback loop. It's always processing and reacting, you know?
And central to this reactive nature is the React-style prompting loop. This is a popular and incredibly powerful architecture, I think first introduced by Yao et al. Back in 2023, where the agent is dynamically triggered by user actions or changes in its environment. Upon receiving a message or an observation, it enters this continuous self-correcting loop. First, action prediction, where it intelligently decides what specific action to take next, like send a message, search a document, maybe reflect. Then, observation, where it meticulously processes the result or consequence of that action. And finally, reflection, where it pauses to think deeply about its ongoing strategy and future plans using what it just observed. This loop continues iteratively until the agent decides to pause and await a next event, or until it has successfully completed the task and gracefully terminates the session. It's a dynamic, iterative, and incredibly thoughtful problem-solving process for an AI. Think of it like a human constantly asking themselves, okay, what do I need to do right now? What just happened as a result? And how does that new info change my overall plan? It's this internal monologue that makes these agents so much more dynamic than, say, a simple chatbot.
And what specific actions or tools can these agents wield within this continuous React loop? They possess a clearly defined set of functionalities, much like a human collaborator would use different communication channels, internal search functions, or maybe personal notes to accomplish a task.
Exactly. First, for accessing internal knowledge, there's document retrieval. The agent can invoke search documents query to scour the initiating user's directly accessible files. This is kind of like searching your own personal hard drive, your local cloud storage, maybe a private document repository. It leverages a standard BM25 index, which is a widely used and highly effective information retrieval algorithm, basically a smart way to match your search query to the most relevant documents. Much like how a powerful search engine quickly finds web pages related to your query. This function returns up to 3 of the most relevant documents based on the query.
Then, for navigating the organization's human landscape, it has people retrieval. It can call search relevant people, query, to intelligently sift through employee profiles, also employing that same BM25 index. The critical nuance here, which significantly contributes to that partial observability challenge we talked about, is that these profiles might be intentionally outdated, incomplete, or imprecise. The agent only receives a templated description of up to 10 of the highest scoring potential contacts. So it's not a flawless directory of perfect expertise. It's more of an informed best guess based on available, sometimes sparse information. This really tests the agent's ability to infer and deduce from limited data.
Okay, and for the actual back-and-forth interaction, there's the communication action. The agent can send message, user ID, content title, to any designated person in the organization. And it can also use resolve person name to translate a human-readable name into a specific user ID, which is essential for precise addressing. This is absolutely crucial for enabling actual meaningful dialogue. And finally, for managing the task lifecycle, there's session management finish. To complete a single turn in a conversation, or send session completed, to gracefully end the entire task and conversation once the objective is met.
And the reflection step you mentioned earlier is particularly insightful and a key innovation in agent design, I think. After each action it takes, the agent receives a textual observation, perhaps the contents of retrieved documents, or the descriptive profiles of potential collaborators. These observations are then simply appended to the agent's internal prompt, which effectively builds a dynamic, evolving memory of the entire interaction, allowing it to maintain conversational context. But here's the clever part. Before taking more actions, the agent can perform these reflection actions. These are essentially internal, text-based scratch pad or chain of thought reasoning steps. They don't generate external messages or return values to the outside world, but they remain in the agent's prompt, allowing the LLM to kind of think aloud, deliberate on what it just observed, process new information, and strategically plan its very next move. This is a subtle yet profoundly powerful feature for enabling complex planning and adaptive behavior. A concept that's often leveraged in sophisticated AI systems and is a core component of how, say, an AI coach by Anil Nathu would guide you to better decision-making processes.
And the overall prompt structure is absolutely fundamental to the entire system's operation. It's not just a free-form conversational AI, right? The carefully constructed prompt that guides the underlying LLM consists of 3 interconnected parts. First, the action descriptions themselves, the precise Python function signatures, and their accompanying docstrings. These explicitly tell the agent what tools it has at its disposal, like search documents or send message, and provide clear instructions on how to use them effectively. Second, and crucially, are the exemplars. These are meticulously manually annotated examples, 4 for each distinct domain, crafted specifically to teach the agent how to navigate common collaborative challenges. This includes handling fragmented information, gracefully dealing with inherently unanswerable questions, and intelligently managing redirection scenarios. These exemplars are vital blueprints for guiding the agent's behavior in truly complex and ambiguous situations. And third, the interaction history. This is the chronological sequence of all events, actions taken by the agent, and observations received, which continuously builds the conversation context for the agent, allowing it to remember everything that has transpired and all information that has been exchanged.
These exemplars are indeed tremendously important because they don't just teach the agent what to do, but precisely how to navigate the specific, nuanced complexities of multi-user information gathering. For instance, listing 3 in the paper details a comprehensive QA exemplar where the agent learns the entire dance: how to search documents, how to search for people, how to confirm with the initiating user, how to resolve specific contexts, how to send messages, and even how to handle multi-turn follow-up questions and redirection scenarios. It's a complete step-by-step blueprint of successful interaction. Listing 4 then shows a similar exemplar for the summarization task, demonstrating how to systematically gather information from multiple distributed sources to compile a cohesive, high-quality summary. This pre-training with examples is what allows the agent to, hit the ground running rather than starting completely from scratch.
Okay, so with the intricate architecture and the innovative benchmark meticulously laid out, let's move on to the moment of truth, putting agents to the test. Results and revelations. What did the researchers actually discover when they ran these sophisticated LLM agents through the rigorous PEOPLEJOIN gauntlet?
Well, the evaluation immediately paints a, let's say, challenging landscape for these agents, underscoring the inherent difficulty of the tasks. The primary measure for PEOPLEJOIN-QA, that answer match metric, revealed a maximum score of only 54.8, achieved by the most advanced reactive agent using GPT-4 Turbo. This tells us right off the bat that coordinating information gathering across multiple simulated human users, complete with all the real-world complexities of fragmentation and partial observability, is significantly harder than it might sound, even for cutting-edge large language models. To put it in perspective, an ideal agent, one that perfectly answers every question while contacting only the optimal, absolutely necessary people, would achieve a score of 100. So yeah, there remains a substantial performance gap between current capabilities and ideal efficiency.
That's a compelling insight into the challenge. Let's break down the PEOPLEJOIN-QA results overview. What did they learn about the performance hierarchy of different LLMs? Which ones did better?
Across the board, LLM performance exhibited a clear and consistent hierarchy. OpenAI's GPT-4 Turbo consistently outperformed GPT-4o, which in turn was superior to Microsoft's Phi 3 Medium. This pattern held true for both the quality of the answers provided, reflected in the batch score, and the accuracy of information source selection, measured by precision and recall. For example, the GPT-4 Turbo reactive agent achieved that 54.8 match score, while the Phi 3 Medium reactive agent, despite being a capable model, only managed 24.4. This stark difference unequivocally highlights the critical importance of the underlying LLM's raw reasoning capabilities and its ability to handle complex, multi-step problem solving.
And what about that reflection step we discussed, where the agent essentially thinks aloud and plans its future moves?
Yeah.
Did the research definitively prove it was helpful?
Yes, the reflection's value was clearly evident and quite impactful. The reactive agent, which incorporates that crucial reflection step, consistently performed better, or at least similarly to reactive NOREF, the variant without reflection, across all the tested LLMs. This robustly demonstrates the usefulness of that internal reasoning step, allowing the agent to better strategize and adapt its next moves in dynamic conversations. For instance, the GPT-4 Turbo reactive agent achieved a match score of 54.8, notably higher than the 48.0 score for the reactive NOREF version. This strongly suggests that explicit thought processes, even when just text-based, significantly aid in navigating complex, multi-turn interactions and improving overall performance.
Interesting. How well did they perform when it came to discerning who to talk to, which ties into that critical communication cost we mentioned?
Right. For information source selection, even the best performing agent, reactive with GPT-4 Turbo, achieved a precision of 0.61 and a recall of 0.89 for selecting the optimal people to contact. Now, while the recall was commendably high, meaning it successfully found most of the necessary people, the precision, meaning it only contacted the necessary people, avoiding redundant queries, was notably lower at 0.61. This indicates significant room for improvement in judiciously choosing who to engage with, further underscoring the inherent difficulty of minimizing communication costs in complex, partially observable environments. It's about getting the right answer, sure, but also about not annoying your colleagues in the process.
Yeah, that makes sense. And how did these sophisticated LLM agents stack up against more simplistic baselines, the ones that don't employ such complex reasoning?
The comparisons against baselines were quite illuminating and really underscored the value of the agentic approach. Message Alliance, a baseline agent that simply sends the initial query to everyone in the simulated organization just once, performed very poorly. It achieved a match score of only 34.6 and, predictably, incurred a much higher average message count, 11.4 messages compared to 9.0 for the reactive agent. This clearly emphasizes the dire need for judicious contact selection and multi-turn adaptive conversations. Simply broadcasting a query is far from effective. Another baseline, message known, which attempts to answer solely from the initiating user's documents without contacting anyone else, scored a mere 19.2. Unequivocally highlighting the absolute necessity of collaboration and external information gathering in these tasks. Finally, the theoretical ideal agent, which would perfectly answer every question and contact only the optimal, absolutely necessary people, scores a perfect 100 of match with an average of only 7.0 messages and 1.5 people contacted, setting an incredibly high bar for future research and development.
What truly stands out to me from the detailed QA analysis are the very specific failure modes identified by the researchers. The agent did surprisingly well at accurately identifying unanswerable questions, achieving an 87.5% match score for those specific cases. That's actually a really valuable capability, knowing when to admit defeat and avoid wasting further effort. However, it struggled significantly with tasks involving fragmented information, achieving only a 50.0% match score. And especially with redirection tasks that explicitly required navigating complex knowledge hierarchies, scoring a mere 38.0%. This clearly highlights the current limitations in sophisticated reasoning and nuanced organizational understanding for these AI agents.
Yeah, and the paper provides a meticulous breakdown of these common failure modes based on a detailed qualitative analysis of 40 examples where the reactive agent with GPT-4 Turbo provided imperfect scores. This offers us incredibly concrete insights into precisely where these sophisticated agents stumble. First, and most prevalent, was failing to contact all relevant users, accounting for a significant 30% of the imperfect cases. The agent simply didn't reach out to everyone it genuinely needed to, leading to incomplete or entirely incorrect answers. This directly speaks to the core partial observability challenge. If the agent cannot accurately deduce who possesses the missing information, it simply cannot acquire it. Imagine you're trying to compile a client report and the AI only talks to the sales team, completely missing crucial data held by customer support or legal. You'd end up with a very incomplete picture.
That's a critical, almost foundational flaw, isn't it? If you don't engage with everyone who holds a piece of the puzzle, you'll simply never solve it.
Precisely. Second, in a substantial 25% of cases, agents employed poorly worded or overly specific queries. The agent asked questions that were far too narrow, rigid, or just poorly phrased, causing collaborators to respond that they didn't have relevant information, even if they did in a broader, more nuanced sense. Listing 9 in the paper provides an excellent illustrative example of this. The agent needed course names for specific enrollments. It initially contacted Cassie, who had course IDs and grades but not names. Then it contacted Nix, who had course names but not enrollment data. The agent, instead of intelligently reframing its questions to combine information from both Cassie and Nix-like, getting the IDs of courses with 5 enrollments from Cassie, then taking those specific IDs to Nix to get the corresponding names, it essentially gave up too soon on a perfectly solvable problem. Its queries were too rigid and failed to adapt. It needed to think more flexibly about how to bridge those information gaps.
That's a very human error, isn't it? Asking the wrong question in the wrong way, leading to a frustrating dead end, only to realize later you had all the information if you just asked differently.
Indeed. Third, claiming incomplete information occurred in 20% of cases. Here, the agent prematurely gave up, informing the initiating user that it couldn't obtain all the required information, even when that information might have been perfectly reachable with more persistent, better framed, or more iterative queries. Listing 7 illustrates this. The agent correctly identifies an unanswerable query, but only after sending a significant number of unnecessary messages to various people, incurring high communication costs for a task it ultimately couldn't complete. While the final verdict was correct, its efficiency in reaching that conclusion was severely lacking.
So it arrived at the right no, but at a high cost in terms of human interaction. That's definitely not ideal for a truly valuable AI assistant.
And finally, orchestration errors, observed in 10% of cases. This is where the agent fundamentally failed to predict or appropriately utilize necessary tools, such as people search or internal document search, leading to premature dead ends. Listing 8 demonstrates this clearly. The agent needed specific card type codes and customer accounts. It initially searched Alice's documents, found nothing relevant, but then crucially failed to even attempt searching for relevant people within the organization. Instead, it immediately informed Alice that the information wasn't available, when in reality, it was indeed distributed among other people in the simulated organization. This represents a fundamental breakdown in its strategic planning and tool utilization abilities. It simply didn't try all the avenues available. The document creation task, PEOPLEJOIN-DOCCREATION, also proved quite challenging for the agents. While GPT-4 Turbo again led in performance, the reflection step, interestingly, didn't demonstrate the same clear and consistent benefit as it did in the QA tasks. This suggests that different task types might inherently benefit from distinct agent planning strategies. Or perhaps the nature of summarization is more linear, requiring less multi-turn strategic thought compared to complex, distributed question answering.
And what were the prevalent failure modes for these document creation tasks, where the goal was to synthesize a summary from distributed articles?
Here, the most common failure modes, again derived from an analysis of 40 examples, were quite illuminating. First, failing to ask follow-up questions for multi-document users, occurring in 38% of cases. If a user possessed several relevant articles on a particular topic, the agent frequently extracted information from only one of them, failing to fully leverage all available information from that single rich source. It didn't dig deep enough to exhaust the knowledge source, basically.
So it got a lead, but didn't follow it through entirely to extract maximum value.
Exactly. Second, similar to the QA task, poorly worded or overly specific queries accounted for 24% of cases. Narrow or imprecise questions again hindered effective information gathering. For instance, the agent might successfully locate relevant documents for a summary on, say, governor, race, GOP, Obamacare, Medicaid, as in listing 10. But if it then only asks for a generic summary instead of specific details across all articles, it might miss crucial nuances or fail to synthesize a comprehensive narrative across documents. And finally, a significant 38% of cases were attributed to orchestration failures. This happened when agents became distracted by a user's tangential comment and prematurely ended the conversation or simply stopped pursuing the original summarization goal. Imagine the agent diligently trying to compile a comprehensive summary. A user sends a small, perhaps unrelated comment, and the agent, misinterpreting the conversational cue, decides to finish the session, assuming the user is done, when the primary summarization task is still incomplete. This indicates a weakness in maintaining persistent focus on the core objective amidst conversational noise and minor diversions.
Okay, this is where it gets really interesting, I think. The researchers took this rigorous testing a crucial step further by including a unique human-in-the-loop case study for PEOPLEJOIN-QA. Instead of solely relying on their sophisticated simulated counterparts, actual human participants played the vital role of collaborators in 100 randomly selected examples from the benchmark dataset. These human collaborators were granted access to the documents associated with their assigned personas, and were specifically instructed to engage as respectful, helpful colleagues in a typical business setting, knowing they were interacting with an automated AI system.
And what were the surprising findings of this human study? Did humans make it easier or harder?
Well, the findings were quite validating for the benchmark's realism, actually. Human collaborators tended to provide slightly longer, more verbose responses, and, interestingly, asked more clarification questions themselves than their simulated counterparts. This naturally led to a slightly higher number of messages exchanged with the agent, about 10.0 messages with humans versus 9.3 with simulators. What's truly intriguing, however, is that the average match score for the agent was slightly better with human users, 50, compared to working with the full simulation, 44.
Wow, that's quite surprising. So better performance with real people. It almost suggests that human nuance, even with slightly longer responses or clarification questions, might sometimes be easier for agents to work with than the rigid, perhaps too succinct responses of pure simulators. It hints that real humans might provide more inherent context, maybe be more forgiving of a slightly ambiguous query, or even intuitively guide the agent more effectively. Exactly. This suggests that the simulated environment, while not perfectly replicating human interaction, nevertheless produces qualitatively similar dialogues and outcomes, as the authors themselves put it, to genuine human interactions. It strongly validates the benchmark's foundational realism, while also offering a tantalizing hint that the inherent adaptability and contextual understanding of human communication might, in some ways, be more amenable to AI agents than strictly programmed simulator responses. This kind of robust, real-world validation is precisely the type of practical insight we value, akin to the actionable guidance provided by an AI coach by Anil Nathu bridging theory with practice.
Okay, so pulling back from the granular details of the benchmark, what does this deep dive into PeopleJoin tell us about the broader landscape of AI-mediated collaboration? How does this research strategically fit into the bigger picture of ongoing AI development?
Right. The paper explicitly positions PeopleJoin within a rapidly growing body of research dedicated to AI-mediated collaboration and complex multi-hop reasoning. While prior work has extensively explored how AI assistants can facilitate human decision-making, like optimizing multi-city travel itineraries, or assist in negotiations, such as scheduling meetings by analyzing individual preferences extracted from conversations, PeopleJoin carves out a unique and critical niche. It specifically emphasizes the distinct yet universally applicable challenges of finding the truly relevant users within an organization, posing precisely apt questions to extract information, meticulously compiling the gathered information from disparate sources, and critically doing all of this with minimum communication overhead on the human side. It's a very specific yet widely impactful subset of collaborative problems that truly mirrors daily workplace reality.
And what about the immense potential and, equally important, the current limitations that these comprehensive experiments clearly revealed?
Well, the experiments unequivocally demonstrate the significant potential of LLM agents to profoundly facilitate complex collaborative tasks, fundamentally transforming how we might gather and synthesize information in the future. I mean, imagine your personal AI assistant autonomously coordinating with 5 different department heads, intelligently navigating their knowledge silos to pull together a critical, comprehensive report for you, all while you focus on other strategic tasks. That's the promise. However, the research also starkly highlights their current limitations, particularly in the most sophisticated forms of reasoning required for truly dynamic information retrieval and the most nuanced human-like interaction. That sub 55% match score for the QA task, coupled with the detailed breakdown of specific failure modes, are clear indicators that there's still a significant and exciting journey ahead in this domain.
This naturally leads us to crucial future directions for this research, as thoughtfully identified by the authors themselves. Where does this groundbreaking work take us next?
One of the most exciting and transformative prospects is enabling these AI agents to learn adaptively over time from their past conversations and interactions. Just as a human colleague refines their approach, becoming more efficient and insightful with experience, an AI could rigorously analyze previous interactions, identifying patterns in who knows what specific types of information, discerning the most effective ways to phrase questions for certain individuals, and continuously improving its overall communication efficiency. By learning from experience, these agents could evolve into increasingly sophisticated, effective, and truly indispensable collaborators. This kind of continuous learning and adaptation is essential for long-term integration into dynamic organizations, as emphasized by any cutting-edge AI coach by Anil Nathu. Secondly, the ethical implications, especially regarding data privacy, are absolutely paramount and warrant significant attention. When these powerful agents gain the ability to access personal or sensitive documents distributed across an organization, substantial privacy risks inevitably emerge. The paper prudently notes that current LLMs may not inherently or fully adhere to strict privacy guidelines, particularly if they are designed to aggregate and synthesize information across various personal data sources. Therefore, future work must place a strong emphasis on developing privacy-centric evaluations and exploring innovative new information access models to proactively mitigate these critical risks. This could involve ensuring data is rigorously anonymized, securely federated, or accessed only with explicit, granular user consent. This is a vital area for responsible AI development and a critical consideration for any organization contemplating the adoption of such advanced agentic systems.
And what about the human side of the equation? Specifically managing the potential burden on human users. We talked about communication costs earlier. How does that factor into future development?
Yeah, that's a huge point. While the fundamental aim of AI is to save human time and effort, an excessive number of AI-initiated requests can paradoxically overwhelm human users, turning a supposed helper into a nuisance. Imagine your inbox constantly pinging with requests from various AI agents. Building agents that can truly minimize human effort, intelligently prioritize urgent requests, and understand human availability remains a significant design challenge. This demands careful consideration of user experience, possibly through implementing Do Not Disturb features for agents, or by having agents subtly learn a user's availability patterns and preferred communication methods. It's about ensuring AI truly reduces rather than just redistributes human workload.
And it's also important for us to acknowledge the inherent limitations of the current PeopleJoin benchmark itself, as the authors very candidly do. I mean, no benchmark is perfect, and understanding its boundaries helps us accurately interpret the scope and applicability of the findings.
Indeed. The current benchmark scope is intentionally focused, covering only 2 specific task domains, question answering and document creation, and is limited exclusively to English. Future iterations of this research could significantly expand this scope to encompass far more complex, multifaceted tasks, such as automated project management, in-depth legal research, or even creative content generation requiring iterative feedback. Critically, it also needs to support multiple languages, which is absolutely essential for global enterprises and diverse teams.
And the nature of the conversations themselves is currently simplified in the benchmark, isn't it? It's mostly one-on-one.
Yes, the conversation topology in the current model simplifies interactions to primarily dyadic conversations, meaning one-on-one exchanges solely between the AI agent and a single user at any given time. Real-world collaboration, as we know from our daily experience, frequently involves dynamic group chats, collaborative channels, maybe even large virtual meetings. This introduces additional complexities that the current benchmark doesn't yet model, such as nuanced turn-taking within a group, addressing multiple people simultaneously in a single message, managing group consensus building, or handling conflicting information from different group members. These are all intricate human dynamics yet to be fully simulated.
And finally, the benchmark doesn't yet account for all the messy, unpredictable real-world factors that profoundly influence human collaboration in actual organizations.
Correct. It doesn't yet account for critical factors like human turnaround speed, how quickly is someone likely to respond, or the inherent reliability of those responses. It doesn't factor in a person's current busyness or workload, which would significantly impact their willingness or ability to respond promptly and thoroughly. And, crucially, it doesn't model the incredibly intricate social dynamics at play in organizations. Things like power structures, internal political considerations, informal influence networks, or established communication habits. These are deeply complex human elements that AI agents will need to navigate far more effectively to achieve seamless, truly human-like collaboration in the future.
This last point, the trade-off between AI autonomy and human control, is a really important ethical consideration that the authors thoughtfully highlight. While AI agents clearly offer the potential to streamline workflows and boost efficiency, granting them too much autonomy without adequate fine-grained supervision undeniably presents risks, doesn't it?
Absolutely, a conservative yet pragmatic approach, where key high-impact actions like sending messages to human colleagues or accessing sensitive documents require explicit user confirmation might be a very prudent path forward in early deployments. This ensures accuracy, maintains vital human oversight, and prevents potential miscommunications or unintentional privacy breaches. This kind of responsible, user-centric design, prioritizing human safety and control while still leveraging AI's power, is a cornerstone of the practical guidance offered by AI Coach by Anil Nathu.
Okay, so after this extensive deep dive into LLM agents for collaboration, what practical insights can you, our listener, take away and immediately apply in your own professional world? Here's a pragmatic action plan to implement these key learnings from the research.
Right, first, identify your information fragmentation hotspots. Start by pinpointing specific areas in your own work, your team, or your organization where information is frequently siloed, hard to access, or requires extensive manual effort to gather. Is it project data scattered across various internal teams and departments, maybe customer feedback buried in different departmental systems from sales to support, or perhaps it's crucial historical institutional knowledge that only a few long-term employees vaguely remember? Identifying these precise areas helps you pinpoint where an AI agent, whether a sophisticated commercial tool like an enterprise chatbot, or maybe a custom solution built with LLMs, could realistically provide the most transformative value. This is your strategic starting point.
Second, prioritize iterative, multi-turn interactions. Recognize that for genuinely complex information gathering, a single query, a one-shot question, simply won't cut it. Just as the PeopleJoin agents intelligently engage in multi-turn conversations, design your own interactions with AI tools and even with human colleagues to allow for natural follow-up questions, requests for clarification, and progressive information gathering. Avoid crafting overly specific initial queries. Instead, approach it as an unfolding dialogue. Start broad, get an initial response, and then thoughtfully refine your subsequent questions based on that feedback. This mirrors how truly effective human conversations naturally unfold and will yield far better results from your AI tools.
Third, focus on clear and contextualized requests. When interacting with any AI agent, or indeed your human colleagues, always ensure your requests are articulated with absolute clarity and provide sufficient, relevant context. The agent's documented struggle with poorly worded queries in the study is a direct, undeniable lesson for how to craft better prompts. Be explicit about precisely what information you need, articulate why you need it, and specify what kind of information would be most helpful. The more precise and context-rich your initial query, the more precise, relevant, and useful the AI's or human's response will be, saving you valuable time and significantly reducing miscommunication.
Fourth, map your knowledge hierarchy. Take the time to think about who knows what within your organization, even if that knowledge is informal or unwritten. If you were hypothetically building an internal people-join-like system, who would be those critical redirecting users who can effectively point you to the right expert, even if they don't have the direct answer themselves? Understanding this intrinsic organizational network can dramatically help you better route your queries, whether you're sending them to a human colleague or strategically leveraging an AI tool designed to connect you to the appropriate knowledge holders. This meta-knowledge of who knows what is an invaluable asset.
Fifth, embrace the reflection mindset. For genuinely complex problems, resist the urge to simply ask once and give up if the first answer isn't perfect. Encourage your AI tools to reflect on responses, diligently identify gaps, and thoughtfully plan their next steps, exactly like the most effective agents in the study demonstrated. If you're utilizing advanced AI tools, actively explore features that allow for chain of thought or scratchpad capabilities, enabling the AI to kind of think aloud and visually show you its reasoning process. More broadly, for your own human problem solving, adopt this mindset yourself. Consciously pause, reflect on the information you've received, identify what's still missing, and then deliberately plan your next strategic move.
Sixth, experiment with AI as a coordinator, not just a doer. This groundbreaking research fundamentally shifts the paradigm of AI's role from being merely a task doer like simply writing an email or summarizing a single document, to becoming a powerful coordinator and orchestrator of information across an entire network. Consider how AI can help you manage complex communication flows, intelligently identify necessary contacts, and meticulously synthesize disparate information across multiple fragmented sources, rather than just generating content from a single input. Think of it as a highly efficient digital project manager specifically for your information gathering and knowledge consolidation efforts.
And finally, and critically, stay informed on ethical AI practices. Pay close, continuous attention to the ongoing discussions around privacy, data autonomy, and human oversight in AI, as thoughtfully highlighted by the authors of this paper. When deploying or simply using AI tools in collaborative settings, always prioritize data security, ensure robust privacy safeguards are in place, and crucially, make certain that you maintain appropriate levels of human control and oversight. Be acutely aware of the trade-offs between full AI autonomy and the absolute need for human verification for key actions, especially when sensitive information is involved. This proactive, responsible, and ethical approach is a fundamental cornerstone of the practical guidance offered by AI Coach by Anil Nathu.
What an incredible journey through the complexities and the truly remarkable potential of AI agents for collaboration. From intelligently navigating fragmented information to meticulously optimizing communication costs, the PeopleJoin benchmark unequivocally sheds light on how large language models can profoundly transform the very way we gather and synthesize knowledge within organizations. It's abundantly clear that while we're not yet at the ideal agent stage, the robust foundation for truly intelligent, adaptive, and collaborative AI is being built right before our eyes.
Indeed. While the research candidly reveals that these agents still have a significant way to go to achieve that elusive ideal agent status, their current progress is undeniably remarkable, especially when considering the realistic, messy challenges they are meticulously designed to overcome. It's not just about building smarter AIs in isolation, it's fundamentally about gaining a deeper understanding of the intricate, often nuanced dance of human collaboration, and then ingeniously designing systems that genuinely enhance our innate ability to work together more effectively, making us collectively more informed, more efficient, and ultimately more successful.
Ultimately, this deep dive encourages all of us to think about AI not just as a tool for individual isolated tasks, but as a powerful orchestrator, a digital conductor, if you will, capable of connecting the dots, bridging the critical knowledge gaps that inherently exist in every organization, and helping to foster more cohesive and informed collective intelligence. The future of truly intelligent collaboration, where AI acts as a seamless extension of our shared human capabilities, feels well within reach, promising a new era of productivity and insight.
And it raises a truly provocative thought for you to consider as you reflect on this. As AI agents become increasingly adept at interacting and reasoning within complex multi-user environments, How might this fundamentally change the very structure of our professional networks, the flow of information within teams, and even the skills we will value most in our future collaborative endeavors? Will critical thinking become even more about synthesizing AI-gathered information, and perhaps less about the raw, often tedious act of information retrieval itself? Something to ponder.
Thank you for joining us today. Visit the AI Coach website for more AI insights.